All right, here's the Chapter 19 notes. This is going to be our last section before the next test, so the last section on out of the next unit. So first thing it says is consider the function, and they give us this. We need to sketch a graph. So in order to sketch a graph, you can make your own table, but it's a good idea just to use your graphing calculator because it will quickly produce a table for you. So I'm going to go to y equals on the graphing calculator and type in exactly what I see. So 2x cubed minus 17x squared plus 42x minus 30. Press graph, and I'll get an idea of what it looks like. There we go. Second graph will give me specific points to plot. So I'm going to plot any point that falls on my table. So the smallest is going to be 1, negative 3. 2, 2, 3, negative 3, 4, negative 6, 5, 5, and the next one's off the graph. And then I'm going to sketch in and make sure it looks like the squiggle that my graphing calculator showed. So it's like this. Something like that. It's close to it. It wants us to find the x and y intercepts. The y-intercept is the easiest one to find. It will always show up in your table. So my y-intercept is where x is 0. So 0, negative 30. Okay. That would be way off my graph. Okay, but this arrow is pointing down and be way down there. Now my x-intercepts are anywhere it crosses the x-axis, and that happens in 1, 2, 3 different places. So it crosses there, turns around, crosses again, turns around, and crosses a third time. So there should be 3 x-intercepts. I just need to find all of them. We're going to use our graphing calculator to do that. So I'm going to go to my table first. If there's anywhere where y is 0, that would be an x-intercept. Unfortunately, none of those show up. Y is not 0 anywhere there. So we're stuck to using second calculate, and we're going to find the 0, which would be our x-intercept. I'm going to start by finding this one. So I'm going to go find my flashy dot first. There it is. So I want to be on the left side, and then I want to be on the right side, and then I don't want to guess. So I like to put my flashy dot as close to it as I can. So my flashing dot is almost directly on top of that x-intercept. And I go to the left because it says left bound. So left, just a little bit, doesn't have to go very far. Enter. Now I'm going to go to the right of the point I'm trying to find. So now I'm on the other side of it. You could go a little further even if you wanted. Enter, and then enter. And it'll tell me that 0, which is the y-intercept. Notice the cursor ends up directly on top of that point, so you can see which point you found. So that x-intercept is 1.270. I'm going to do the same thing for the next one. Second calculate, 0. I like to put my dot right on top of what I'm trying to find, or as close to it as I can. I want it to go to the left, so I press left once or twice. Enter. I go to the right of the point I'm trying to find. Enter, enter. And the dot goes right to the point it's showing you, and it is right on that x-axis. Shows me 2.5, 0. And my last one is over here. Second, calculate 0. I'm going to put my dot directly on top of what I'm trying to find. Ooh, it's kind of bouncing. That's as close as I can get. I want to be on the left side. Enter. Scroll to the right. I'm on the right side of it now. Enter, enter, and it says, that's a scientific notation, very, very small number. So we get 4.73. So those are my 3 x-intercepts. Next it says find the coordinates and nature of any turning point. So the coordinates of the turning points are where like the top of a mountain or the bottom of a valley. So this top of a mountain will be a turning point. It changes from increasing to decreasing. And then at this point down here, it changes from decreasing to increasing. Those are the places where a function changes direction. You can sometimes find them in your table, but I like to use second calculate. And this one's a maximum, that one's a minimum. So that one's the highest and then the lowest. So I'm going to find the maximum value first. I like to do this because sometimes it's at a decimal. They can be hard to find. So I put my cursor right at the very top of the mountain. I'm trying to find that maximum. I go to the left side of it because it says left, around to the right, enter, enter, and it gives me the maximum. And that would not have shown up in my table. So I have a maximum. Local maximum is the best word, but just a maximum is fine. Is at 1.819. So how about 82 and 2.186? So 19. So this is a local maximum. This down here is a local minimum. It's the lowest point in relation to the stuff that's around it. So second, calculate minimum. I want to find this point down here. So I go to the left of it, enter, across around to the right of it, enter, enter, and I have a local minimum of 3.85 and negative 6.15. Okay. Discuss the behavior of the function as x goes to infinity and x goes to negative infinity. This is called end behavior. So end behavior of the function has to do with what direction your function is pointing, to the left and to the right. So as x goes to infinity, so as x gets really, really big, so I'm going to look at the graph I have up here. As x gets really big, this way, my function is going up. So what we say is, as x goes to infinity, f of x, which is the name, is our function, goes to infinity as well. So as x gets bigger, y gets bigger. We do the same thing for our negative. So we go, as x gets smaller, our function is pointing down. So as x goes to negative infinity, our f of x goes to negative infinity as well. F of x can be replaced with y, that's fine. So this has to do with what direction the arrows are pointing at the end of your function. So as x gets bigger, line goes up. As x gets smaller, line goes down. So as x gets very big, as x goes to infinity, the function goes up, infinity. As x goes to negative infinity, our function goes down to negative infinity. Domain and range. So domain is our list of all inputs, anything you're allowed to plug in. The things that mess up the domain are going to be square roots and square roots and fractions are the typical things that are going to mess up our domain. Up here, we just have a normal polynomial. This is a cubic. It's to the third power. It's just a polynomial function. So this will be the domain of all real numbers. So you can choose either notation, negative infinity to infinity. It's called interval notation. Or you can use set notation. You can pick. It does not matter. All x such that x is a real number. You can plug in any number you want. There's no restrictions. You can plug in anything. For our range, this is our list of all outputs. So this is how low does the function go and how high does it go. So I've got an arrow pointing down and I have an arrow pointing up. So this means it goes all the way down and all the way up. So we have the same answer. Negative infinity to infinity, or all y such that y is a real number. There are no restrictions for this function. Our domain and range are both negative infinity to infinity. The next question wants us to solve this equation. If you have an equation to solve that you don't have a strategy for, so we don't have a strategy when we have an x in the exponent, then we're gonna rely on our graphing calculator. We can always, when we're solving an equation, graph the left and graph the right, and then find where they intersect. So I'm going to go to y equals, I'm going to graph 3 to the x power, And then I'm going to graph the other side. 2x plus 1 graph. There's my first line. There's my second. It seems like they might intersect right in there. I'd like to zoom in because they might intersect once or twice. I'm not really sure. So I'm going to zoom in right there. So zoom in. And if I move this little dot, there's a little tiny dot on the screen where I'm thinking they intersect right in here. If I press enter right there, it zooms in on that spot. So that can be handy if you kind of know where they intersect. Oh, and look at that. They're going to intersect twice there. So that was good that I zoomed in because there's actually going to be two solutions. When I was zoomed out, it looked like there might only be one. It was hard to tell. So I need to find this point of intersection and that one. I'm going to look in my table first because sometimes they show up in the table. And sometimes they don't. Oh, so this one shows up in the table. 0, 1, 1. Oh, they both do. Yay! And then 1, 3, 3. Those are both of those intersection points. So the y values are equal for my first and my second line at these 2 points. So my solutions will be x equals 0 and x equals 1 are my two solutions. Now let's say you get a question and it doesn't show up in the table, or you can't find it in the table for whatever reason. Second, calculate, intersect, and you just put your little flashy dot close to the spot and then press enter 3 times. And it gives you 1, 3. So x equals 1 is one of them. Second, calculate intersection. I'm going to scroll over to the other one. Enter, 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 and it gives me the other one, 0, negative 1. Okay. So x equals 0 and x equals 1. Now, if you ever want to check yourself to see if an answer to an equation is correct, just do 3 to the 0. That's 1. And then I'm going to do 2 times 0 plus 1. So the left and the right equal when x is 0. When x is 1, 3 to the 1 is 3. 2 times 1 plus 1 is also 3. So when you plug in 0, the left and the right equal, good. When you plug in 1, good. It all checks out. This one specifically says find the point of intersection of these two lines. They give us y equals x squared and y equals 2x. We're going to type both of those into y equals to figure out where they intersect. So I've got x squared as this one, and then 2 to the x for that one. Ooh, I'm all zoomed in, so I'll probably want to zoom out. Oh, maybe not. Look at that. Maybe my zoom was perfect. If you didn't zoom in on the last one, I can go through how to do that again. This is what your standard zoom would look like. And you can see it's going to cross right there, and then it also crosses up there. You can check your table to see if any values show up in here. This one does. So it looks like they intersect at 2, 4, because they both the y values are 4 here. Oh, and there's the other one, 4, 16. So they both show up in the table. You could also go, make sure there's not another one. I don't think there would be, but you never know. Those don't seem to be, yep, those aren't going to be. Okay, so those are our two intersection points. Once again, second, calculate, intersect is your other choice. You get close to the intersection point with your flashy dot and press enter 3 times. Why didn't that work? Why don't I zoom in a little bit? Right there. So I picked the intersection point and zoomed in on it. Oh, maybe that's one that didn't show up in my table. So that's an additional intersection point. So there's one. Let's see, what were the other ones in the table? We had 2, 4, and 4, 16. So let's write those down. 2, 4, 4, 16. And it seems like there is a third one. So from my graph, this point is another point of intersection. It happens at a decimal. So negative 0.767 and 0.588 is that intersection point. Maybe there's another one. So let's go back to Zoom Standard and see if we can see another one. So that was right there. And then there's another one over there at 2, 4, and then 4, 16. Those are going to be our last two. So sometimes you might need to look at your graph a little more closely to kind of see if there's an additional one. So that would be an additional one. Typically on IB, they're going to maybe give you a pre-existing graph, and so you'll know how many intersection points you're looking for on a question like this, or they might even tell you, and so that might be a little more helpful as far as like not being so open-ended about this. All right, I'm going to pause here. This gets us through the first part of Chapter 19, and then there'll be an additional video to go through the second part.